Hello and welcome. Today, we are going to tackle a real powerhouse topic, one that shows up all the time in your exams, physics fields. I'm telling you, if you can master this topic, you are going to give your scores for WAEC, JAMB, and NECO a very serious boost. So let's just jump right into it. So let me ask you a question. What do things like gravity, the static shock you get from a blanket, and a simple magnet, what do they all have in common? Well, the answer is fields. Think of them as invisible zones of force that let objects push or pull on each other without ever touching them. It's a huge idea in physics, and today we're going to break it all down. Okay, here's our mission plan for today. First, we'll look at what the examiners actually expect from you. Then we'll dive deep into gravitational, electric, and magnetic fields. After that, and this is the best part, we're going to solve real past exam questions together. And we'll finish up with a super quick recap to lock it all in. Alright, let's get started. The first thing we need to do is look directly at the official exam syllabus. Why? Because this makes sure that every single thing we cover today is exactly what you need to know to get those high marks. No guessing, just facts. See this? This is straight from the WAEC syllabus. Part 4. The examiners want you to understand the main concept of what a field is. Then, you need to know the big three: gravitational, electric, and magnetic. And finally, their properties and how we use them. Don't worry, we are going to cover every single one of these points. Right then, let's start building our foundation. We are going to look at two fields you actually deal with every single day: gravitational and electric fields. Now, the definitions and especially the formulas here are absolutely crucial, so please pay close attention. So, what exactly is a field? Well, it's just a region in space, an area where an object can feel a force even without anything touching it. You can think of it as an invisible force zone. For example, the sun is pulling on the earth right now through its massive gravitational field. There is no rope connecting them. Okay, first up, the gravitational field. This is the force zone that exists around any object that has mass. And here is the most important thing you must remember. It is always attractive. Gravity only pulls things together. It never ever pushes them apart. This is a key idea. And trust me, it often comes up in those tricky NECO conceptual questions. Now, for the maths, the strength of a gravitational field, which we call G, is calculated with this formula. G equals capital G, capital M, all over R squared. Now, don't let the letters scare you. G is just the universal gravitational constant. It's a special number in physics. M is the mass of the big object creating the field, and R is the distance you are from its center. You absolutely must memorize this formula. Let's look at a classic example. Calculating G right here on the surface of the earth. The first thing you do, always, is write down the formula. That's a free method mark right there. Then, you substitute the values. Be very, very careful with those powers of 10 on your calculator. When you do it right, you get the familiar 9.8 meters per second squared. And from there, finding the force on any object is easy. Just F equals mg. Simple. Now, let's move on to electric fields. It's actually very similar to a gravitational field, but this one is created by electric charges instead of mass. But here's the key difference. You have to remember this. Electric fields can be both attractive and repulsive. You know this already. Opposite charges attract, while like charges, they repel. And here is the main formula for electric field intensity, which we call E. Now, does this look familiar? It looks a lot like the gravity formula, doesn't it? It's E equals kq over r squared. In this case, K is Coulomb's constant, Q is the charge creating the field, and R is the distance. Okay, here's a very common type of problem where you have a uniform electric field between two metal plates. For these special situations, we can use a much simpler formula, E equals V over D. So we just plug in the voltage and the distance they gave us, and we get our answer. And it's important to note that the unit, volts per meter, is exactly the same as newtons per coulomb. Alright, you've handled the basics. Excellent work. Now, let's move on to our final field, the magnetic field. And after we've understood that, we are going to compare all three fields side by side, which is a very, very common style of question in your exams. So, what makes a magnetic field? Well, it's produced by magnets, of course, but more importantly, it's made by moving electric charges, like a current in a wire. And here is the absolute most important point. You have to get this. A magnetic field only exerts a force on other moving charges. I'll say it again. If a charge is just sitting still, there is zero magnetic force on it. This formula right here is a huge favorite for JAMB questions. F equals BQV sine theta. Here, theta is just the angle between the direction the charge is moving and the direction of the magnetic field. But what about the direction of the force? For that, you need Fleming's left-hand rule. Okay, everybody, take your left hand. Point your first finger in the direction of the field. Point your second finger in the direction of the current. Your thumb will then point in the direction of the force or the motion. See? First finger, field, second finger, current, thumb, motion. A nice trick to remember it. Let's use that formula. The problem says the electron moves perpendicular to the field. Perpendicular means the angle is 90 degrees, and the sine of 90 is just 1. So that makes our calculation much easier. The formula simplifies to F equals BQV. After you substitute the values, just be very, very careful when you're multiplying the powers of 10, and you get the correct final answer. This table is perfect for revision. I seriously recommend you take a screenshot of this right now. It shows you everything you need, the source of the field, its nature, and the key formula, all in one place. Just remember, mass for gravitational, charge for electric, and moving charge for magnetic. Okay, we've done the theory, we've done the examples. Now for the real deal. Let's put our knowledge to the test with real past questions from WAEC, JAMB, and NECO. This is where it all comes together. Okay, let's begin with a WAEC question from 2013. Now this one is very direct, very straightforward. They give you the charge, they give you the force, and they ask for the electric field intensity. This is a simple application of the definition, so please don't let the big numbers scare you. You can do this, and here is how you solve it. Remember, for WAEC, the first thing you must do is write down the formula, E equals F over Q. That's a free method mark right there. Then you substitute the values, calculate carefully, and you have your final answer. These are the kind of straightforward marks you can definitely get in your exam. Now, let's look at a typical JAMB question. You see, JAMB often tests your direct knowledge of formulas. You don't need to calculate anything here. You just have to look at the options and identify the correct expression for electric potential. This is exactly why knowing your formulas by heart is so important for JAMB. Here's the key thing to know. The electric field, E, is proportional to 1 over R squared, but the electric potential, V, is proportional to just 1 over R. They are related, but they are different. So when you look at the options, you just need to find the one that has a single R on the bottom, not R squared. This immediately tells you that A is the correct answer. And finally, a NECO question. You'll find that NECO loves to test your conceptual understanding of the topic. This one asks, in which of these fields can you not experience a repulsive or pushing force? Just think back to the fundamental properties we covered at the very beginning. The answer is really simple if you remember the basics we talked about. We know electric fields can repel and magnetic fields can repel. But what about the gravitational field? It is always attractive. It only pulls. It never pushes. Therefore, the correct answer is the gravitational field only. Wow, we've covered the theory and we've walked through some real past exam questions. Excellent. Now it's time for a final recap and some very important exam tips. Get ready to screenshot these next few slides because this is your ultimate revision guide. These 4 formulas, they are non-negotiable. You absolutely must have them memorized before you walk into that exam hall. They are the essential tools you need to solve any problem on this topic. So, please learn them. And here are some pro tips to help you get every possible mark. First, units, units, units. Never forget to include them. Second, always label your diagrams clearly, especially for WAEC theory and practicals. Third, show all your working, every single step. And a personal tip from me, always draw a quick sketch of the problem. It really helps you see what's going on. And please remember this, you can absolutely do this. Fields is a high-scoring topic that comes up year after year. With the knowledge you have now, you are more than ready to face any question the examiners throw at you. So go into your exam hall with confidence. If you found this lesson helpful, please like this video, share it with your classmates and friends who are also preparing for WAEC, NECO, and JAMB, and subscribe to our YouTube channel right now so you don't miss the next topic. Also, visit Examkp.com for thousands of free practice questions and answers. Let's smash these exams.